Pictures from Curiosity just came back, and they show Mars's skies are blue at sunset. During the rest of the day, they're orange. It's the exact opposite of Earth. What is going on here? Greetings, Earthlings. Julian here for D-News from YouTube Space LA. Alright, be honest. If you're watching this at some point, you probably imagine what it would be like to travel to distant worlds. But while you're lost in your spaceman spiff daydreams, have you ever considered what it would be like just to look up at the sky? We have our whole lives under the same sky, so it's hard to fathom anything else. Even in Interstellar, a massive, imaginative sci-fi movie with 3 exoplanets, all the skies still look pretty Earth-like. Well, as it turns out, the view from the surface of another planet is pretty surreal. Let's talk about the 4 rocky planets in our solar system, the ones where you can actually get your boots on some solid ground. We'll start with Mars and work our way in. As stated, Mars's skies usually look reddish-orange. Well, that's because dust made of iron oxide, more commonly called rust, is just everywhere. It gives the surface of the planet its color, and there's enough of it in the thin atmosphere to scatter red light around and turn the whole sky red. That is until sunset. As the sun gets close to the horizon, the sky around it looks blue. That's because sunlight has to travel through more dust at that sharper angle, so more and more of the red light gets scattered while the blue light pierces through and reaches our eyes. It's actually the same process as what's happening here on Earth. The difference is the makeup of the atmosphere. Nitrogen and oxygen scatter shorter wavelengths better. And if the S-cones in our eyes were more sensitive to violet, the sky would actually look purplish blue. Conversely, at sunset, the reds and oranges get to us because they don't get filtered out. So, atmospheres make for sweet sunsets, right? Nah, unless you're on Venus. Venus has an extremely thick atmosphere of mostly CO2, and you can't see the sun through it. In 1982, the Soviet probe Venera 13 sent back colored photos from the surface of Venus, showing the sky and ground to appear yellow or orange. If you could see the sun through the gas, though, it would appear to rise in the west and set in the east, because Venus spins counter to its orbit. But if you think that's cool, it's nothing compared to Mercury. Mercury has almost no atmosphere, so the sky doesn't scatter any colors, but instead looks black, even during the day. But that's not what would strike you most. The most surprising thing would be the sun. It would be huge for a start, at least 2.2 times bigger in the sky than it is from Earth. And since Mercury has the most eccentric orbit of any planet, sometimes it would look 3.2 times bigger. Even weirder, it would seem to have a mind of its own. There are 2 points on opposite sides of Mercury where, on alternating years, the sun would come directly overhead, stop, grow, head back east a little, stop, and continue westward while shrinking again. It would be swirling overhead at the biggest it's been all year for about 16 Earth days, and temperatures would hit 700 Kelvin. It would basically be the angry sun from Super Mario 3. From other places, it would appear to rise, set briefly back in the east, then head west. Then next year at sunset, the sun would peek out from the west again before going away. The reason the sun looks all indecisive is because of a strange interplay between Mercury's rotation speed and the shape and period of its orbit. One rotation around Mercury's axis is about 58.6 Earth days, and one orbit around the sun is 87.9 Earth days. So, 1 Mercurian year is exactly 1.5 Mercurian days. This translates to 1 complete day-night cycle every 2 Mercurian years. The elliptical orbit accounts for the sun's weird sky dance, too. Mercury speeds up as it nears the star until it's traveling faster than its rotational speed, so the sun stops, then heads backwards. Mercury slows down when it zooms away again, and the turning of the planet makes the sun travel across the sky once more. Now that is a sky to behold. So, Mercury's orbit is still pretty zany, but the rest of the planets seem to have calmed down, which is good because it's possible Jupiter once went through a wild phase. Trace explains right here.
All that motion cleared the way like a wrecking ball. It could have even destroyed any other protoplanets, which formed before the 4 inner planets we have now.
While you can't really stand on the gas giants of the outer solar system, they do have a lot of solid moons with interesting quirks. If you want us to cover those or any other spacey topic, let us know in the comments or find us on Facebook or Twitter @DNews, and I'll see you next time.